So today we're going to start a new topic, and it's a chemistry topic, and it's all to do with calculations. I know some of you might not particularly like working with numbers and might not like maths, but the maths involved is it's not difficult, I promise, and it is a really important topic in terms of your exams and your GCSEs for one, but also just for chemistry in general. These calculations that we're going to be looking at are used to figure out the amount of chemicals that you need each time you do a chemical reaction. So these type of calculations will be used routinely by chemists every single day. They're really important to chemistry. And even if you don't like maths, I promise you, they're not difficult calculations. You've got a calculator. All you're ever going to be doing is multiplying and dividing numbers. You just need to know which numbers to multiply and which numbers to divide. Because it's a calculations topic, you will need a scientific calculator. Ideally a scientific calculator, not just the calculator on your phone. And if you have a periodic table in your science book, it would also be useful to have that out in front of you as we go through this topic. Okay. Today's title specifically is called Relative Formula Mass, and we are going to be looking today at what relative formula mass is and how to calculate it. Relative formula mass is often just written as a symbol, a capital M and a lowercase r. So it's called relative formula mass, and that would be the symbol. Before we look at relative formula mass and how to calculate it, I just want to make sure that everyone is comfortable reading chemical formula. So I have written down a common example of a chemical formula, which is H2O, which you should hopefully know is the chemical formula of water. And we're just going to look at this as an example to make sure that everyone knows how to read chemical formula correctly. So when I look at this H2O, okay, I can tell by looking at it straight away that there must be two elements. And the reason I know that there are two elements is because there are two capital letters, and each capital letter will represent a different element. So straight away when I look at this, I know it must have two elements, and it's got two elements because there are two capital letters. If I want to know what elements they are, then I need to look at my periodic table. So I've got a capital H. I look at my periodic table and I see that a capital H means hydrogen. I've got a capital O. I look at my periodic table and see a capital O means oxygen. So I know that the two elements I've got are hydrogen and oxygen. I've also got a number in there. I've got the number 2. So when you're writing chemical formula, it's really important that you write the number as subscript. And by subscript, I mean that it should come off the line. Your number should not be the same size as the letters. It should be coming off the line, written small. If you write it as this, H2O, in your exam, that's wrong and you're not going to get the mark for it. You need to make sure you're writing that number small, okay? And this 2, the number, always refers to the elements that it comes after. So the 2 comes after the H, which means that you have got 2 hydrogens. I've got 2 hydrogen atoms. There is no number coming after the O. If there's no number, it means you've just got 1. So I've got 1 oxygen atom. Okay, so H2O, 2 hydrogens, 1 oxygen. Okay, another common example of formula will be NaCl. So when I write this formula, you'll see that I've got 4 letters, N, A, C, and L, okay? But again, when you want to know how many elements you've got, you're looking at how many capital letters you've got. Okay, that is a lowercase l, by the way, not a capital I. So I have only got 2 capital letters, a capital N and a capital C, which means I've only got 2 elements. I don't have 4 elements, I've only got 2 elements because I've got 2 capital letters. And when I want to find out what elements they are, when I go to my periodic table, I'm not just looking for capital N, I'm looking for capital N followed by a small a. So that small letter is going to go with the capital letter before it. So I'm looking for a capital N and a small a. And when I do that, I find that it is sodium. And then I look for a capital C and a small l. And when I do that, I find that it is chlorine. So the elements I have are sodium and chlorine. And you obviously will always have a periodic table with you in your exam. Okay, there are no numbers in this formula. If there's no numbers, you means you've just got one of each. So I've got one sodium and I have got one chlorine. Okay, if we look at another example, okay, I'm going to do CuSO4. Okay, so slightly longer one. Okay, once again, if I want to know how many elements I've got, I'm counting capital letters. Okay, I've got 3 capital letters. That means I've got 3 elements in there. If I want to know which elements they are, I'm going to look at my periodic table. I've got a capital C followed by a small u. That's all one element. Then I've just got a capital S and I've just got a capital O. So I'm not going to be looking up SO on my periodic table. 2 capital letters means 2 separate elements. But I am going to look up Cu. When I look up Cu, I see that it is copper. When I look up S, I see that it's sulfur. And a capital O would be oxygen. So the elements I've got are copper, sulfur, and oxygen. When I look at the numbers, okay, there's no number after Cu, which means I've only got 1 copper. There's no number after S, which means I've got 1 sulfur, but there's the number 4 written subscript, so nice and small, next to the oxygen, and that tells me that I have got 4 oxygen atoms in there. One more example, I'm going to get you to do some for yourself, okay? In some chemical formula, you will see that you have got brackets. So a classic example would be this, okay? So the first thing I'm going to do again is I'm just going to look at how many elements I've got. How many capital letters do I have? I have got a capital C, a capital O, and a capital H, which means I have got 3 elements. To find out which ones they are, okay, I'm going to look up capital C and small a on my periodic table. Then I'm going to look up my capital O. Then I'm going to look up my capital H, okay? The Ca is calcium, and the O and the H we've had already, so we know they are oxygen and they are hydrogen, okay? This time, when I'm looking at the number, I see that the number comes after a bracket. And what this means is that every element inside the bracket is multiplied by the number outside the bracket. Oxygen is inside the bracket, so I multiply oxygen by 2, which means I have got 2 oxygens. Hydrogen is inside the bracket, so I multiply hydrogen by 2, and that means I have got 2 hydrogen atoms. Calcium is not inside the bracket, so I am not going to multiply calcium by 2, and I've only got 1 calcium. So only if it's inside the bracket do you multiply it by the number that is outside the bracket. I'm actually just going to do one more for you because there's another kind of example that I want to show you. If I did, no, I need it to be, okay. If I did AlSO4, and I would need 2 and 3. Okay, so this is a slightly harder one. Okay, that's an L, by the way, a lowercase l. So when I want to see what elements I've got, I look for my capital letters. I've got a capital A followed by a lowercase l, a capital S, and a capital O. So I've got 3 capital letters, which means I have got 3 elements. Capital A followed by a small l is aluminium. So the AL is aluminium. And I can see that the aluminium is followed by the number 2. Actually, I'll get to that in a second. I'm just going to write down my elements first. I've got aluminium, I've got sulfur, and I've got oxygen. So Al, S, and O, they are my 3 elements, aluminium, sulfur, and oxygen. Okay? So I said any element that is inside the bracket must be multiplied by the number outside the bracket. Okay? Aluminium is not inside the bracket, so I can completely ignore the number outside the bracket. However, aluminium is followed by the number 2, which means I have got 2 aluminium. Got 2 aluminiums, okay? Sulfur is inside the bracket, so I'm going to multiply it by the number that's outside the bracket, okay? Got 1 sulfur inside the bracket, there's a 3 outside, that means I have got 3 sulfurs. And then I look at oxygen, okay? Oxygen inside the bracket, I've got 4 oxygens inside the bracket, and then I've got a 3 outside the bracket. So you're always multiplying what's inside the bracket by what's outside the bracket. You only had one sulfur, so it was 1 multiplied by 3 was 3. But you've got 4 oxygens, so now it's 4 multiplied by 3, and that's going to be 12. So you have got 12 oxygens in total. Okay, I'm going to get you to do some by yourself now. Okay, so I want you to have a go at these yourself. So I've written out the formula. I know you don't have periodic tables in front of you most likely, so all I want you to do is look at the formula and then tell me how much of each element you've got. So the first one, CaCl2, how many calciums do you have? How many chlorines do you have? So if I was doing this one, there's no number after Ca, so I'd write Ca equals 1. But for chlorine, Cl, there's a 2, which means I've got 2 chlorines. Okay, for the next one, hydrogen, there's only 1. Nitrogen, there's only 1. But oxygen, there is a 3. So just go down through the other 6 and do them yourself. You don't need to tell me what element they are. You just need to tell me how many of that element you have got. Sorry, just the last one as well. That's a bracket, and then that's CO3 followed by a bracket. Okay, that might be a bit confusing to read. So press pause, do these questions by yourself, and then press play when you're ready to see the answer. Okay, so here are the answers. I've just filled them in for you, so just mark your own work. I'm hoping that they're relatively straightforward. I'm just going to go through the ones with the brackets, okay? So there's magnesium's not in the bracket, so you've only got 1 magnesium, but oxygen is in the bracket, so 2 oxygens. Hydrogen is in the bracket, so you've got 2 hydrogens. With calcium, again, calcium itself not in the bracket, so you've just got 1, but nitrogen is inside, so you've got 2 nitrogens. There's 3 oxygens in the bracket, and it's 3 multiplied by 2 is 6. You're always multiplying. In maths, brackets mean multiply. In chemistry, brackets mean multiply. Aluminium's not in the bracket, you've only got 1 of them. Nitrogen, you've got 3 of them. Oxygen, you've already got 3 inside the bracket, so it becomes 3 times 3 is 9 oxygens. Aluminium here, it's not in the bracket, but you do still have 2 of them. There's a little number 2 there. So I've got 2 aluminiums. This is a carbon here. It's inside the bracket. I've got 3 carbons, and then oxygen again, 3 in the bracket, multiplied by the 3 outside the bracket gives you 9. So please mark them and make sure you have gotten them right, because if you can't read chemical formula, then you can't do relative formula mass. And if you can't do relative formula mass, you will find that this topic does become a lot more difficult. Okay, so make sure you've corrected all of those. Pause if you need to. I'm going to move down the page a little bit so that we can look at relative formula mass. Okay, so to look at relative formula mass, I'm going to use the symbol for relative formula mass, which is capital M followed by, actually I'm going to write out, I'm going to write relative formula mass is represented by this little symbol. And from now on in notes, I'm always going to use this little symbol to represent relative formula mass. Okay, and it's kind of, you can kind of get it from the name what exactly you are going to be doing. You are going to be looking at a chemical formula like we've just been looking at, and you are going to look at the mass of that chemical formula. So the mass of the elements in the chemical formula. So for example, if I were to look at H2O, okay, we know that we have got 2 hydrogens and 1 oxygen. Okay, because we can read formulas, we know we've got 2 hydrogens and we have got 1 oxygen. But I want to know what the relative formula mass of H2O is. Okay, for that, I need to go to my periodic table. And when I do, I will see that all of the elements on the periodic table have 2 numbers next to them. Okay, so if I look here at beryllium, it's got a 9 and it's got a 4. Lithium's got a 7 and it's got a 3. Magnesium has a 24 and it's got a 12. Okay, it's always got one number that's bigger than the other. The bigger number is called the mass number. Okay, and this is the exact periodic table you'll have in your exams. Okay, and it comes with a little key. Okay, this key tells you how to read your periodic table. It tells you that the top number is relative atomic mass. Okay, so that 9 is the relative atomic mass. It tells you what comes next is the atomic symbol. So Be is the atomic symbol. Then written small is the name. So in this case, it's beryllium. And then the smaller number underneath is called the atomic number or the proton number. And that's going to be 4 in the case of beryllium. So it does tell you on the periodic table that you will use in your GCSEs that the top number in each case, which is the bigger number, that is your mass number. And it is the mass numbers that we are going to be using when we calculate relative formula mass, okay? So it's always going to be the top number, which is always the bigger of the two numbers. Now, hydrogen is a slight exception to that because both numbers next to hydrogen are 1. But for every other element, you will see that the number in top is bigger than the number on the bottom. And it's the number on top, the bigger number, that is the mass number. Okay, so by looking at my periodic table, I can see that the mass of hydrogen is 1 because it's got a 1 at the top. And I can see that the mass of oxygen is 16 because it's got a 16 at the top. When I want to calculate relative formula mass of H2O, okay, I have got 2 hydrogens, okay, and they each have a mass of 1. So that's 1 plus 1. I've got 1 oxygen and it has a mass of 16. And all I need to do then is add these numbers together and I see that in total, water has a relative formula mass of 18. So relative formula mass of H2O is 18. Each hydrogen has got a mass number of 1. There are 2 hydrogens, which is 1 plus 1. I've got 1 oxygen, which has a mass number of 16. So 1 plus 1 plus 16 is 18, okay? These numbers, I'm going to write next to them, mass numbers from the periodic table. Please make a note of that for yourself because when you look back on this, you might not know where you've gotten those numbers from and you might be confused, okay? So they're the mass numbers from the periodic table. If I looked at another example, relative formula mass, so I'm using MR as my symbol, relative formula mass of NaCl. Okay, when I look at my periodic table, the big number next to sodium is 23. So sodium has a mass of 23. I've only got 1 sodium, so I'm only going to write down 23 once. Chlorine, the big number next to chlorine is 35.5. I've only got 1 chlorine, so I write down 35.5, and then I add them together, and I get 58.5, and that is the relative formula mass of NaCl. Okay, if I do another one, relative formula mass of Cl2. Okay, Cl is chlorine, and I have got 2 of them. So again, I go to my periodic table. I see the big number next to chlorine is 35.5. I've got 2 of them, so it's 35.5 plus 35.5. Add them both together and you get 71. If I did the relative formula mass of H2SO4, okay, I have got 2 hydrogens and the mass number of hydrogen is 1. So that gives me 1 plus 1 for hydrogen. I've only got 1 sulfur because there's no numbers after sulfur. The big number next to sulfur on my periodic table is 32. So it's going to be plus 32. And then I have got 4 oxygens. Okay, the big number next to oxygen is 16. And I've got 4 of them. So I can write this as 16 plus 16 plus 16 plus 16. And add them all together, or you could also just write 16 multiplied by 4, which will be a little bit easier. You add them all together, and you get 98. Okay, so that's all formula mass is. Once you can read chemical formula, you're just using your periodic table. You take the big numbers from your periodic table, and you just add them together. Okay, I'm going to give you a few to do. Don't worry if you don't have a periodic table. I'll give you all of the information that you need to do the exercise. Okay, so here are the questions I want you to practice. I've given you 6 different chemical formula, and I want you to find the relative formula mass of each one. I've provided you with the big numbers from the periodic table. So for CO2, you need to know that the big number next to carbon is 12, the big number next to oxygen is 16. For HCl, the big number next to hydrogen is 1, the big number next to chlorine is 35.5. Again, you can't round that, it has to be 35.5. So I've given you the mass numbers from the periodic table for all of the relevant elements. What you need to do is add those numbers together, paying attention to how many of each element that you've got, okay? And remember, when you get down to the end, any number inside the bracket is being multiplied by the number outside the bracket. Press pause, have a go with those 6 questions, and press play when you're ready to see the answers. Okay, so here are the answers. I've put a box in pink around the final answer, so you can just quickly pick out the right answers and mark your work. If you've got all of those correct, then you're done, okay? We're not going to do anything else in the video. If you haven't gotten all of them correct, then I'm going to talk through them now. But if you've already gotten them all right, you don't need to watch the end of the video. If you've gotten any of them wrong, then please keep watching so that you can pick up where you made your mistake. CO2, okay, you've got 1 carbon and 2 oxygens. Carbon has a mass of 12 from the periodic table. Oxygen has a mass of 16. You've got 2 oxygens, so it's going to be 12 plus 16 plus 16. So they're the 2 oxygens, gives me 44 in total. I've got 1 hydrogen and 1 chlorine. Hydrogen's got a mass of 1. Chlorine is 35.5. Formula mass of 36.5. For HNO3, you've got 1 hydrogen, 1 nitrogen, and 3 oxygens. The hydrogen has a mass of 1. The nitrogen has a mass of 14, and you've got 3 oxygens, so that's 3 16s. You can write 3 times 16 or write 16 out 3 times. Add all of this together and you get 63. CaCl2, you've got 1 calcium and 2 chlorines. That's 40 for calcium and 35.5 times 2, or 2 of them, for each of the chlorines, 111 in total. I've got 1 magnesium, 1 sulfur, and 4 oxygens. The mass number of magnesium is 24. The mass number of sulfur is 32. And you've got 4 oxygens, so 4 16s. Add all of that up together and you're getting 120. The last one, you've got 1 aluminium, 3 nitrogens, and 9 oxygens. So that's 3 times 3 is 9 oxygens because it's inside the bracket. Aluminium is 27. You've got 1 aluminium. You've got 3 nitrogens, so it's going to be 3 14s. And then for oxygen, you are going to have 9 16. So I've just written 16 times 9. Work out 16 times 9 and then add it up with the rest of it and you'll get 213 as your final answer. Okay, so that's relative formula mass. You need to be able to read chemical formula, know what elements you've got present, know how many of each element you've got present. And once you know that information, then you're just looking at your periodic table. You're always going for the top number, which is the mass number. You're adding those mass numbers together to find out the total mass of the formula. Okay, so that's relative formula mass. Just one note, I'm going to be sending you homework to do on, oh no, actually, I'll talk about homework on the actual lesson on Wednesday.